Tonight we're going to take a look at the Solidworks and Mastercam Solids. So inside of Solidworks we have add-ins, and under the add-ins, Solidworks Cam, which is Camworks derivative. I mean, pretty much is Camworks. Is now embedded with Solidworks, the freebie. As long as your license is active, you are going to have 2.5 axis SolidWorks Cam. Right? And then the HSM is the Autodesk product, is also a cam modeler that lives inside of SolidWorks. And then we come to the Mastercam Solids. My intent is to do a little comparison, talk about the learning curves. The nice thing about Mastercam Solids, having gone through the 2D, basically the flat version, is that going over into the solids, you're looking at a very similar user interface. Setting up planes, being able to manipulate the geometries, those are going to be slightly different, but the operations and the interaction is going to be very similar. The one that I don't have access to, that'll probably have to wait till spring for it to get installed, is SolidCam. So that'll be the fourth one, actually the fifth one, because Fusion 360 and HSM Works, Fusion 360 Cam and HSM Works are pretty much the same thing. So one of the videos we'll take a look at Fusion. So I click on the add-in, I hit OK, it's activating it for this session. I don't typically have the cam modelers open with the software. And this is a demo version. Since I don't have the license for the solids, I download this much like the class demos, just so we can take a look at it and have that interaction. So while it's thinking about it, I should have gone ahead and added in and talked about it afterwards. We may pause if it goes on. So when Mastercam launches, it's going to add an info center to the task pane on the right, and it has some information. If we have it set up for the news feeds, it will go out and retrieve some of those. Basic directories that you might be interested in, the tutorials, documentation, shared locations, those types of things. So if we just click out into the work area, that's going to kind of clear everything out. I was debating on doing the assignment 6, but I want to keep these kind of simple so that they're a pretty close comparison. And I don't really know how they'll react if I load program on top of program, because the thing to keep in mind is the toolpath, all the background information that is traveling with this CAM package is being saved to this part file. So one of the things that we might consider is, and depends on if it's a licensed version or not, whether it will let me work in assemblies. So a lot of times, especially with the CAM and the SolidWorks CAM and CamWorks, I want to be in the assembly mode because I have more flexibility. If I decide I need multiple work offsets, they're easier to manage. I can do a lot more things out of the assembly and not affect the original documentation, the original part file. And in some ISO documentation control systems, I technically cannot change that original document without it going through a revision process. If I add a line that says, oh yeah, I'm just going to tell my face mill to follow that line. No, you can't do that. It has to go through revision. You change the document. All right, so in order to kind of combat some of those things, taking an assembly creates a completely separate document, a manufacturing document that is controlled under a separate set of rules. So it's one of the considerations. To make this easy, I'm going to go into the front plane and open up a sketch. We're just going to do the block with a hole. And so sketch off the rectangle. We'll make it 6 by whatever we are, 3. And for the hole, I want it to always stay centered, so I'm just going to use a center line. Find that midpoint. and we'll make it, yeah, 2 inches will work. And then I'm going to extrude that out. Depending on which way I extrude it, usually I want that front plane, and I try to work in the Z negative. It makes sense to me. So if we tell it that it's a 1-inch block, then by default, most of the cam packages are going to pick that origin. What we don't know if the cam system is going to pick up the same Z, or if it's going to rotate over, which, yeah, it's pretty minor at that point. But a lot of the cam packages are going to see that origin. It's going to be X, Y, Z. And if I've drawn from the origin, I've already picked, I'm already going to have that coordinate system established. All right, so on the tabs, then we go over to the toolpath, and wow, that looks pretty similar to the 2D version. All right, our standalone version has the same tool set. And when we come over to the Mastercam tab, the ribbon bar has a lot of the same types of things. They're maybe a little bit rearranged, but we have that information. So like I was saying, one of the first things I want to observe is where exactly is the X, Y, and Z for the cam, because if it doesn't follow the Solidworks triad, then we're going to have to make that adjustment. So that would be one of the first things I want to check is under the planes. We'll need to establish a new, or let's see if we go into the front, WCS and tool, then now I have the correct for the orientation of this part. So when we look at the standalone version, Alt-1 is our top. And so in this case, just like we're telling at the front, it is going to still default to the top. All right, so no big deal, just something we check. If I need to make adjustments, I can shift those coordinates or go in and make further selections. All right, then we're into our standard toolpaths. Some of the basics. I haven't seen the nesting, so we'll have to take a look at that. Some of the utilities, and one of the things I'd like to identify, we have the configuration. Well, since I haven't selected the machine just yet, defaulted to mill. I was going to say I'd like to see the tool manager. So those were toolpaths. One quick check. Simulation, dependency. There's no little double arrows over here. So we'll pick that up as we go. All right, so same types of things. If I double click on the files, we're going to see very similar. I would want to go into that configurations, the machine control definition, so that I could set my defaults. Anytime I'm changing something more than 1, 2, 3, 4 times, I'm going to start looking for those default locations and having it built into the software that it's going to do it that way from now on. And then the stock setup. One of the things that we haven't really done in the standalone is use a solid, but one of the things we can leverage out of the Solidworks is that I could create a separate body, or I could import a part that is the stock and place this part around, or place the stock around this part, and then use the stock as a shape for the setup, and then that would pick up the information. So since we are at the 0, 0 location, it's finding the XYZ. If I go to select corners, I should be able to pick and have it shift. So, would have expected that to move. So let's go back and see what it did. Oh, you know what? That's out of the planes. I'm just defining the stock. I was thinking origin. So let's just go back to all entities. There we go. So 3 by the 0.5 in Y, 6 by 1 by 3. Okay, so that establishes the stock. There we go. Now I can see kind of the red dashed lines over the top of the part. If we're going to machine this down, maybe I'm getting material that's 1 1/4. So Let's see, Z value. So because this is skewed in the 3D environment, if I give it another 1/4 inch, I just need to identify the 1 inch. And then we can give it a little bit more stock. Oh, that centered itself. Oh, because we are still at the origin, then that should be 0.625, and we'll see if that sneaks it down a little bit. All right, so we're still having to manipulate the origin since that number was at the midplane of the part. It added that extra 1/4 inch, 1/8 inch to one side, 1/8 inch to the other side, and I needed to shift it 1/8 inch to keep the top of the part at the top, or the top of the stock at the top of the part. All right. So let's just stay with the one tool. If you've seen the operations, and again, trying to keep that comparison. So mill toolpaths, we're going to set this up as a facing operation, and definitely a different interface for picking the chains. So Mastercam front, on our selections, I'm not getting the tooltips, it went to filters. Display selections, chaining operations. And one of the things you'll want to be careful of in the selection, let's see, faces, that should be surfaces, that should be features. Let's go ahead and select the body. And we get the face. And then the chain. So chain 1, let's see what chain 2. So one of the things you'll want to watch for is that it picked the face and it sees both the external and the internal geometry. So chain 2 as a facing operation would not necessarily cut that bore. But if I come over to chain 2 and I delete it, now when we go to chain 1, it's going to see that as the facing operation. All right, so as you make those selections, I could have just as easily picked the outside edges as I did the face, and then sometimes depending on the program, it'll just select the body, the extents of the body, and call it good. So once we have a chain, now we're looking at a very similar setup. We have the chain geometry, we already verified the side and that it picked what we wanted. And then setting up the tool. Let's go ahead and select a library tool. And like I said, we'll just pick a 1/2 inch end mill. And let's see if that was a 4 flute, 2 flute. See what we got here. Cutting length, shoulder, finalize, offsets. And so yeah, 4 flute. So let's bump it back down to a 2 flute. And finish. We could put in a few other numbers. So spindle speed, again, are we setting up for the tool room mill? Do we have 4,000, 6,000, 7,500, 10,000, 12,000, 15,000? I don't know that I do anything that I would ever want a 30,000, but it would be fun to think about. So if we have the 1/2 inch tool with a 10,000 RPM spindle, then I'm probably going to run this at 9,000 RPM, and our feed rate will be up around 30 to 40 inches a minute. Plunge rate, until I get that set, I'm going to still probably back that down by at least half, and we'll put in our comment for the face. Cutting parameters, low, we'll just zigzag. I do kind of like the dynamic. It starts at the outside and works towards the end. Zigzag also works pretty well. So we'll just leave the defaults. No, I don't want to leave anything on the floor. There are no depth cuts. The linking parameters, 0.25 above, 0.2. Top of stock is 0, depth is 0. That all makes sense. All right, so if I was going to be removing more material than just that basic 10,000ths cut, then I would want to bump these up accordingly, make sure that I'm not wrapping into stock if I haven't given it enough on those extensions, which were the across overlap, approach distance. So we've given it the radius of the tool, which if we have oversized stock and we've set our 0 internal, we're going to touch a little bit. So maybe that goes up to 60 or 70% until we know until we know what we're dealing with. All right, so and then we have the turns. Not real fond of those 90-degree turns, so let's go with the move between cuts, and we'll do the high-speed loops. We still need to regenerate our dirty operations, and so now it's going to go through those moves a little bit different. The contour then, same thing. We're going to pick that lower ledge. It did not go all the way around. So let's see, what did we, selection filter is on for edges. Nope, that must have been faces. So, nope, we'll just set it to the filter. All right, so we're going all the way around. I'm just using the middle mouse wheel to rotate. And then when we go over to check for the chain, we're going to have one chain. The direction is to the inside, and we would be climb cutting on the interior. So we need to reverse the side. So that puts it outside. That's going to keep us in conventional. So when I reverse, well, it also changed the direction of the arrow. So we are now in climb on the exterior of the part. So again, looking at those arrows, checking the direction, checking the side to cut. Now we can go on with the operation. We'll stay with the same tool. Did not keep my my numbers, so still just a little hesitant on the outside. So if we call this a rough, and I'm interested to see if they fix something. So we have the rough cut, the cut parameters. So let's leave it in where, so it initiates the G41, 42, no stock to leave on the walls. Well, actually, if we're going to make this a rough, let's leave 10 thousandths on the walls, nothing on the floors. Lead in, lead out, I'm just going to extend, and don't need to be at the midpoint. So length, let's give it the 0.3, and make sure it's extended. Carry it over to the other side. Breakthrough amount, let's go ahead and go another 10. And then the multi-passes, let's see, I already passed that one then if I went past the ramp. And the depth at incremental should read where I selected that chain at the bottom, so we're going to have to verify that. And let's switch over to ramping, 3-degree angle ramp. One way for open contours, no. All right, we'll go ahead and see what we get. All right, so you can kind of see that plunged pretty quick at 3 degrees going around the part. So ramp depth instead, maybe we're 1 inch. Maybe I want to tell it to go 200 thousandths per, if that's going to be per loop. All right, so it's quite a few passes, but I would be doing something similar if I was going to step and repeat. So I'm going to save this real quick. I'm not sure where it's going. All right, so that was the Mastercam MCM Solid. Oh. And maybe we'll get back to that. All right, so previous times I've done this, there has been an issue with the copy and paste, which is one of my favorite things to do in the standalone, and I've always been a little nervous. Yep, still does it. Poof, gone. So I don't know if it does, if it's just the demo or if it's in the licensed version too, but if it did that more than once, I would be very upset. Oh, something came back right as I was closing it, so. All right, so make sure you save. And then because this is the same, now it may be, again, something that I'm doing or something I don't understand about solids because I'm not using it all the time. But the other side of it is once we go back to the contour, and we have that those same settings. Most of our settings should be retained and come over. So let's go to the chain. We're going to look at that direction. So this time I'm just going to reverse the direction first, and it goes to the proper side to cut. All right, so tool, retained my feeds and speeds, but for a finish pass, I'm going to slow that down, maybe 6,000, and we'll go to 20, and I'll leave it at 20, and this can be the finish. All right, not real worried about holders at this point. I've had the collisions. Probably didn't need the wear for the ramp and the rough, but it doesn't hurt to have it on. And stock to leave on the walls now goes to 0. And our lead in, lead out can stay with the extend. Breakthrough amount still goes past a little ways. Linking parameters 0 and to depth. All right, so again, because we put that chain on the bottom of the part, it's reading that pretty much automatically. So the one that I don't see is because I told it to extend, did I tell it to extend enough? Or did I tell it to extend the right way? Because that doesn't look exactly like what I wanted for that lead in. All right, so let's take the lead in, lead out. Oh, and you do have to be careful because when I get in a hurry, I do that quite often. I give it 0.3%, which was only 15 thousandths. That's not going to do a whole lot, is it? So easy to make mistake, but you know, it comes back to, again, being able to read those toolpaths, make decisions as you go. And if I did it on one, can guarantee I did it on the other one because I did not go back and check it. All right, so those are the things you have to check and catch while you're going through the programming phase. All right, so at 2-inch, let's go ahead and run one of the pocket routines, or we could do the 2D high speed and have the dynamic mill go in and open it up. Let's just make it a pocket. We'll do one of the more traditional. All right, so we'll check the chain. When I highlight it, I should see the arrow in climb and with the correct side to cut. All right, so tool, I'm going to stay with those. Since it changed operation, I'm also going to lose my feeds and speeds. So I'm going to go back up to that more aggressive. Okay, I didn't like my 20, and then this is going to be the pocket. All right, so cut parameters, stock to leave on the walls 0, leave on the floor 0. I'm going to use the finishing and the breakthrough amount. So of the choices, parallel, high-speed steel, true spiral. Again, true spiral is going to generate a lot of code, but it's also probably going to be the closest to those high-speed cuts. And so the step over percentage, I'm going to drop it down to about 30%, which will be 150 thousandths. So we'll reduce that engagement. The entry motion on the helix. Again, I still think the helix at times can be a little bit longer, a little bit more involved than what we need it to be. So if I have that room, I would probably be in the ramp. So it's a toss-up. It's one of those you need to try. I think we discussed this before, is you need to try the helix, but because it's making all of those turns, it also seems like it takes a little bit longer, where the ramp is just kind of back and forth, back and forth. How aggressive, what's the material? You know, there's lots of reasons to go between the two. So minimum radius of 0.25, maximum radius of 0.5. If I were to drop that down to 0.1, that'll tighten it up a little bit. And pretty much is setting the overlap for the tool at 0.25. I think it's basically it's rotating about a point. All right, so about the center point. Z clearance of 100 thousandths, XY clearance, we can get it a little closer if it needs it. So I'll let it get close. We already saw that the 3 degrees was maybe a little aggressive, and so if we go with a plunge angle, we'll drop it down a little bit. Let's see, the roughing I already set at the ½ inch, so it will ramp in, step over, get close, and then on the finishing pass, we're telling it to engage where, finish the outer boundary, start the finish pass at the closest vicinity. Since I don't have any islands or other walls to worry about, we can keep the tool down and only machine at the final depth, just in case. And then the lead in, lead out, way too big. Let's go with like 100. 100, 90 should be okay. Transfer it all over. Shouldn't be any depth cuts if we've got continuous engagement, and we'll put it in at the 10,000ths breakthrough. Same thing, 1/4 inch. I still think that's a little bit close. 200 thousandths, and then the top of the stock is 0, and the depth from the chain of 0. We'll see what we get. All right, so we're starting above. It's removing a good portion of that material before it starts the step overs. And then it's working out to the finish pass. All right, so that gives me toolpath group 1. Let's go ahead and highlight, make sure everything's checked, and then we'll turn off the turn on the display so I can turn off the display. And then with the machine group, we are seeing that material on the back side. So let's go ahead and try for that. Group, new toolpath group, if we want it to stay in, and I should have done it from the machine group, so let's go back up. Move after. Alright, so we get the toolpath group, and I need to set a new plane, so we're back into the plane manager. And let's go ahead and could copy from the back. And when we do that, my Z value, see if I can move this over to where I can pick it up. Set the current plane in the origin. There we go. Nope, it's still rotated on me. So let's make that current. Okay, that has the correct direction. And then let's see if we go to the 1 inch. Double check and make sure that that's the tool plane. That's still on the kind of the opposite corner from where I'd like to be. So in the X, see if it'll just let me pick it. There we go. That was what I was looking for. So we pick up the 0, 0, 0 in the back plane manager, and so this is pretty much where I'm going to be machining from. And then we can go ahead and hit OK. And then we're just going to add the facing operation. So this time, let's go with the edges rather than all of the whole face. So I can pick whatever geometry is available, and then we just need to double check. It's going to cut the interiors, so we're okay there. And our tool still shows up. We're doing the one tool wonder. So cut parameters, zigzag, extension, still a little bit more on the extension. No depth cuts, but we know that we left about 1/4 inch depending on how much we step down. This is where I'm going to be a little more paranoid about these linking parameters. As soon as I turn this block over, and I know I have 1/4 inch of material, those retracting feed planes cannot be as low as they are. And so cut parameters, I think we're okay. Yeah, it's still a pretty good step over, but and then we get to the linking parameters. So now all of a sudden my retract at least 0.5, and if I want to be above that raw stock, then the feed plane needs to be probably about 300 at least. And then top of stock is showing at 0.25, but technically, do I want to treat it as a negative value, or do I want to have it go to 0 in the program? All right, so depending on the post, how it functions, I think I want it to be top of stock at 0. It's seeing the stock that we generated, right, as there, and depending on what makes sense to you, how you want to manage it, I pretty much want the stock to be on the part so that I can adjust those Z values up and down, and what I'm ultimately ending up with is that face. So instead of in the program it programming to positive 0.25 or ending up with some numbers that I might not recognize, I'm still telling it to clear in the retract in the feed planes and having it feed to 0. And then from 0 picking up those numbers, or and instead of a negative 0.25 or a positive 0.25. All right, so we've got enough clearance. It comes in. It shows me that it's removing the material. And again, it's going to be one of those, try it, see what makes the most sense to you. I try to keep my logic maybe not too crazy, but sometimes it still ends up kind of going there. So let's see, what are you selecting? Nope. All right, so well, it generated, but it's still telling me the toolpath program number. All right, so much like the standalone, we are seeing that there is that one, yeah, I went to the back one, and everything else is in the Mastercam front. So we go ahead and save that, and then we'll pick up the simulation. So machine simulation, settings, run, backplot, or we can come back over to the standard, verify. And it should be in the same orientation, so I think I have to turn it over. And happen to click back out. So let's go ahead and see if we can rotate that over. If that's the only one selected, then, oh, there it goes. That still stepped out and left a pretty good tab there in the middle, so, and machined off the backside. All right, so what is the advantage of doing all of that over being in the standalone? If I go back into Solidworks, and I know that there is a method inside of Mastercam, I have not successfully made it work. So I would put more of that on me than I would on the program, and I get a little frustrated. And then I was like, I'll bring the geometry over and just reapply toolpaths. In the solids, though, if I decide this part needs to be 8 by 5 with a 1-inch hole, when I rebuild that, all of those planes, one or more items has changed. Do you want to update? Yes, I do. And has been marked dirty. And then we go back and all of those are selected, and I tell it to regenerate the toolpaths. Stock did not update, but I didn't necessarily tell it to. So if we went with the bounding box instead, it should be on the body. Let's pick one of the select corners. All right, so if it has those vertices and it retains those vertices, now the stock may move with it. Don't see any dirty operations, but the facing, it's ready to post. As long as I didn't make anything too crazy, I don't see any problems. But as I go down through this, all I had to do was change those numbers, and all of my code updated out of the box. Right, so the associativity is immediate, I guess, is the point. All right, so then we would go post this. We would be ready to take it out to the machine. Whatever adjustments we made are ready to go. All right, so I'll give you a quick overview. Again, don't want to do anything like super complicated with this. The one tool wonder is fine. You have very similar workflows, but you have that added advantage of living inside of this solid geometry.